So this Metasploit tool will take some time. It is really important tool, guys. So this is the payload that was generated by the NSF Venom. I will just copy till this here, till this part. It is thinking that I am writing a C language. That's why it is giving me a variable name too for a final copy. So it is generating a payload of 1408 bytes. Final C file is 1408 bytes. So I'll just copy this out. And what I will do in replacement of this one, the malicious, the string, I will replace that. And what I will do is I will save this thing, the malicious payload. Okay. So right now, this area is where I'm controlling the EIP value. And this EIP value will be pointing to the start of this binary, this payload. Okay. So I hope, guys, you got in knowledge like what I'm trying to do over here. The same thing that I've explained over here, that the EIP value will be pointing to the stack memory over here, that is 0022 F730, and that's where the my malicious payload is starting. Okay, and that's what you are seeing over here. The malicious payload is starting from here, and what I will be doing is that let me quickly execute that. So before that, let me so yeah. So what I'll do, I'll quickly restart this system, and okay, and this time I will kind of run this, and if I execute this time, so let me just go to over here, let me do CL here, and if you see the software is running, and this time if I send the malicious payload, there's some issue with the code, so let me just clear it out. So I'll remove this semicolon and it should be done. So this is the software is running. The software is running this time. And this time, guys, thing is that because this malicious payload is a correct one, the software will, you will know that the software will actually not crash. Okay. And this will actually it will not let the victim know that someone has already been in the system, and they are kind of their system is compromised because their software will be running. And the other thing also what will happening is that I am, as an attacker, I'm able to log in into that system using this vulnerability, but because I'm logging the system by a vulnerability, there will be no artifacts like 4624 login type 10 or login type 3 on the system. So the thing that we analyzed before in the forensics part, those all data you will not be seeing in the mem copy in this artifacts. So if you for any kind of investigation where you are dealing with zero-day exploit, you will not be seeing any kind of artifacts that is related to like login event like 4624 or 4648 or 4720, the one that we saw last time yesterday. Okay, so now what I will do is that I will execute this code, and I hope that it works in the second time. Okay, so if you see the code is actually running, and if you see the software is actually running, and there has been no crash, right? And now the thing is that as I told you guys that it is listening on port number 4444. Let me do one thing. What I will do now is that because that payload is executing on port number 4444, what I will do, I will try to connect to that payload. So I will try to connect to that this one 0.220 over port number 4444. And as soon as I do that, if you see, I got the command prompt. So that operating system has been hacked, right? So I have got the remote control of the system with that payload by that bug, and I can execute anything on that system without the knowledge of that victim. I can get to know its IP addresses. I can even, like, let's say, open Notepad. Let's see if it works. It doesn't work. Let's say start Notepad. Okay, you see the Notepad got started over here. So using the Mac terminal, I am now able to connect to the Windows XP operating system, and that system has been totally hacked out. I can do whatever thing I want on that Windows XP machine remotely without even the knowledge of the victim. Okay, and there will be no artifacts on the system related to the forensic artifact that we have seen earlier, like 4624 and other details. And I have a total control. Even I can do shut down the system, I can do restart, and whatever thing I can create malicious file, I can download more malware in the system. Whatever thing is the possibility is endless. And I hope, guys, it was interesting. We looked at from a very basic over here, CPU, register, all the things, stack memory, how stack memory works, how assembly code works, the EIP register, and then we actually made out the malicious payload. And this is, guys, how the Metasploit payload also work internally. Okay, so now you guys will have a confidence that, okay, if you encounter, let's say you are executing any Metasploit payload, and if it doesn't work, what you can do is that with this base knowledge, you can even make that Metasploit code work. Okay, you can make certain changes to the internal code of the Metasploit and fire that up, and you will see that the next time so as a normal pen tester, what will happen is that the Metasploit code doesn't work. So pen tester will think that, okay, that software might not have some vulnerability like that. But as an exploit writer, if you have this kind of knowledge, you can surpass the knowledge of pen tester. And let's say the normal pen tester give you a wrong result saying that the system is not vulnerable. And with this knowledge, you can kind of quickly know if that Metasploit failed or passed. And then you can make some changes and make that Metasploit code work and get the full control of that system and get the correct result to the leadership saying that, okay, that system yet has that vulnerability. So I hope, guys, it was quite interesting to see that from a terminal of Mac, I was able to reach out to the window operating command prompt. Okay, so this is how the attack normally works in the real sense, how the Metasploit actually does. So Metasploit has nothing, but it has the database of these all payloads in one place. It knows what vulnerability is. It had a database of what all vulnerabilities exist for software, and that's all for this lab demo. I hope it was interesting. It was easy to understand for you guys. Okay, so if you have, guys, any question, feel free to let me know, and let me see if I have a documentation regarding the ASLR. Just give me 1 second. Now, one of the questions that was asked was related to the ASLR and extra protections that are there in the new operating systems, right? So one of the things I can kind of showcase you guys is this one. Okay, so thing is that here, the thing is that this was a software which was running on Windows 7, and only the depth protection was off for this ASP, but the ASLR was on for this one, the ASLR protection. So what you can do is that, okay, let's see that software. I opened that in Unity Debugger. Okay, in Unity Debugger, and then actually there is another tool in the Unity Debugger is called as Mona. Okay, using Mona, actually you can again kind of create a pattern, the one that is string that I was generating, let's say of 18,000 characters, and I saved that payload as something like exploit1.asx. So what this ASX is all about, there's an MP3 file which actually has a vulnerability of buffer overflow attack, and the thing is that it has a vulnerability where if you load a playlist, a very big huge playlist, it will actually execute that buffer overflow attack. Okay, so I created a malicious payload over here which is like exploit1.ax, which is actually the playlist that the mp3 file is expecting. And when I executed that, thing is that it is, if you see, the EIP value was it got crashed, and the EIP value was pointing to the random character that was generated by this Mona keyword pattern create. Okay, it is for the Windows 7 machine. Okay, and once that's done, thing is that what we did is that, again, similar to how we found out where that payload specifically was, which was